I don't have slides. I'm here to give you a summary of a very lively workshop that happened yesterday. If you missed it, that's on you. It was a fun discussion on the intersection of quantum technologies and the space sector, which I did observe, attending a lot of conferences which are a little bit more business or policy oriented like this one. It's not a very common intersection discussed in workshops. There's a lot of quantum computing for finance, for pharma discussions, and the aerospace sector is kind of conspicuously absent in the usual narrative of conferences, despite the market size indicates that it's having a pretty interesting share, and also there's a lot of applications that are potentially transformative. So we did have an introduction to the field at the beginning. Then we did have a keynote discussion presented by Dr. Caroline Mercer, which is the Chief Technology of NASA headquarters. I'm going to tell you a little bit about this. And then after that, we had some perspectives from different groups and entities. We did have Lavida Cooper from NASA Goddard discussing quantum networks. We had Bernie Siri from USRA discussing academia engagement with NASA. We had Peter Brereton from NASA Goddard discussing quantum sensing missions and opportunities, and Dr. Pranav Bogokale from Inflection discussing what industry can do and does in the field. And then we had lively Q&A. So summarizing chronologically what happened, let me just tell you, we started discussing the importance of the fact that both quantum and space are two frontiers, and that exposes us to serendipity in a somewhat unprecedented and unique ways because of the real being at the edge of things quadratically, if you want. We did discuss some interesting use cases for space and Earth science, including monitoring the Earth with sensors which have unprecedented accuracy, and then the ability to use generative AI and next-gen quantum machine learning for both weather modeling and inverse design of computational fluid dynamics, which is currently undergoing a revolution in AI, thanks to AI methods that are replacing things which are instead well established via model-based direct algorithms. We did discuss aeronautics and engineering use cases, including combinatorial optimization for air traffic management and ability to simulate materials that might be useful for aerospace applications. We do know that, for example, anti-corrosion is a problem well identified by both Boeing, Airbus, and many automotive companies as a chemical problem that should be solved with next generation methods. We went briefly touching upon autonomy and the use of AI with quantum for defense, and of course precision navigation and timing opportunities with some deep dives after all. And then we did touch upon as well the fact that there is opportunities for fundamental research in space which are unique, and the International Space Station is unique assets that we have, and the future commercial space station will be as well. We did brainstorm a bit about the role of NASA as a potential power user and an applied user in the landscape, and how all these technologies, new sensors, artificial intelligence, quantum networks, transduction, quantum computing, and simulation of complex physics are interconnected and interdependent, and doing only one will actually will be doomed to fail to some extent. So that was part of the introduction, and then we went we went very inspiring, a very inspiring talk given by Dr. Mercer, which showcased that NASA is really doing quantum sensing today. It's not like something that's aspirational. There are a lot of experiments right now which are fully qualified, and missions that fully qualified as quantum sensors. That she discussed the X-ray microcalorimeter spectrometer as a unique device that only NASA is using. We have a lot of sensors in the superconductor with superconducting technology, including single photon detectors and communication receivers for remote sensing. They're fully, qualified quantum sensors. But in general, she made the point that NASA is committed and has been committed for the full spectrum of quantum information science and engineering. And that's a strategic direction for NASA, because quantum is just another tool for NASA, she said, for exploration and for advancing the mission of the organization. And international collaboration is part of the DNA of NASA, so that's actually a great benefit, because this is a global endeavor. She gave a great assist to also the discussion of Dr. Peter Brereton, which discussed more in detail the Cold Atom Laboratory, which is an actual semi-autonomous lab for cold atom research in space, in low Earth orbit on the International Space Station. You can actually have dual species potassium and rubidium mixtures for doing very complex atom interferometry experiments, including studying quantum liquids and quantum matter at geometries which are not possible if not in the absence of gravity. It's a great fundamental physics example. And then how one of the next moves for NASA is to add complex atom interferometry for gravity gradiometry in the form of, for example, the GRACE follow-on mission, where in a single spacecraft you will have 2 atoms interferometer that will be able to detect at unprecedented sensitivity movement changes of mass on the Earth. So all of this was actually elaborated by Dr. Brereton, which also discussed the Quant Pathways Institute, which is a collaboration with academia, including University of Texas at Austin, Caltech, Santa Barbara, and others, and UC Colorado, NIST, multi-agency, multi-stakeholder, and for the mission of quantum sensing for space applications. There were discussion about atomic clocks, how important they are. Also, Dr. Gokhale from Inflection discussed the importance of atomic clocks and for precision navigation and timing, which is overwhelmingly a huge high-impact application of quantum technologies. Lavida Cooper discussed networks and how they are, discussed as enabling technology. There's a lot of uncertainty around networks because they are, but they're so omnipresent. They're so important also in the history of how our information technology infrastructure developed and how important it is to involve the IT sector into the creation of this infrastructure. Now, we just had an amazing talk for 15 minutes on quantum networks, so I'm not going to recap everything that Lavida discussed on the importance of quantum networks, but importantly, that discussion led to a few questions from the audience on the importance of quantum memories, for example, and how NASA, for example, is approaching the absence of a quantum memory. And there was a discussion about how the industry will provide quantum memories because they're needed for so many things. And so NASA is very ready to adopt as first adopter in the infrastructure of quantum sensing and quantum networks, the appearance of reliable quantum memories. Moving on, we had Dr. Siri discussing University Space Research Association, which happens to be also my employer and my organization, and now that was created at the request of NASA in 1969 to make sure that academia and NASA can interface in a productive way. In that case, was for rocks of the lunar surface. But going forward, it discussed a lot of programs that benefit from this tight collaboration. And so and hundreds of universities are engaged by the University Space Research Association for research at NASA, including my own group, Quantum, focused on quantum computing, which primarily works with the Quantum Artificial Intelligence Laboratory. We, I think, concluded with the last presentation on the subject from Dr. Gokhale, the inflection, that discussed the fragility of GPS, how much of a threat that is. And it's not only a space thing, it is a thing which impacts infrastructure. I'm sure that multiple speakers have discussed this, and our solutions by atomic technology are ready to take over and to help on the ground, not only in space. And that is definitely some aspects that represent some serendipity that I discussed at the beginning on pursuing space applications that can benefit society as a whole. So with this, I think I reached the end of my scattered notes on everything that happened yesterday. Once again, it was a very lively conversation. I believe that the community at the intersection of space and technology needs to consolidate, and people need to know each other way more. There are other fields in quantum information science which are applied, like quantum for sustainability, for climate change, which are much better at talking to each other and getting a common voice and traction. And I think that the uniqueness of the space environment and the opportunities of quantum technologies are deserving a community that discusses this regularly, not only at the Quantum World Congress once a year. And I think I'm on time. Oh, Q&A on a readout. Okay, I didn't expect that. But of course, if somebody wants to ask questions about what happened yesterday, please feel free to. Or, yes, please.
So this isn't specifically related to what happened yesterday, but I mean, also what happened yesterday, but also two, I think so for just in general, quantum readout. I know that's like an issue. I don't know if this is necessarily related to the space work. I mean, it's related to everything, but just quantum readout. So do you think there's fragmentation in the way that quantum computing companies and governments and organizations are just dealing with readout in general, like just the quantum readout method?
Your question was similar to a question that was raised during the workshop about what's the biggest challenge, for example, in quantum networks. Let me just answer in a very generic way. I mean, we are all very fighting the noise. That was one of the messages discussing, even more than transduction or other kind of problems that in the integration of quantum technologies. We're very cognizant that in all the stack between computing, sensing, communication, right now there's no reliability and fault tolerance, reproducibility. There are not the quality assurance that standard technology allows you to have, and that is probably the biggest issue in working right now, doing R&D on the field. So Readout is just one of the many issues when you're trying to acquire a quantum information signal and make sense of it, it was discussed a bit.
Okay, and also just a recommendation. I don't know if that person is here today, but QAlchemy is a software that specializes in readout, and they have really good. Their QAlchemy is a really good company for specifically quantum readout. So
wonderful. Thank you.